Yeah. Good afternoon. How many are there? 17. What about others? What about others, ma? 17 participants out of 64, 65. Yes. What about others? Okay. In the process of this chlorination, ma, disinfection by chlorination. Okay. Chlorination, we have used this chlorinator apparatus used for the disinfection by chlorine. Chlorine is known as chlorinator. Here it is a large tower. It is a large tower containers in which there is a number of buffalo plates are there, from which we are pouring from the top raw water. From this side, raw water is nothing but the river water, which contains impurities, and we are adding the chlorine from this side. Okay, chlorine solution in the form of in the form of chlorine gas or in the chlorine solution is introduced from the top of this chlorinator, and they gets reacts here. What happens in the inside this chlorinator? What happens means the chlorine reacts with the water H2O. It forms a HCl. HCl plus hypochlorous acid H4Cl. Here H4Cl acts as a hypochlorous acid. Okay, hypochlorous acid. This acts as a powerful germicide, which kills the germs or pathogenic bacteria present in the water. Which kills the germs or pathogenic bacteria present in the water. Here, this gets thoroughly mixed during this passage. Okay, through the tower from the filtered water. About 0.3 to 0.5 milligrams of chlorine is sufficient for this. Here disinfected water is taken out from the outlet at the bottom. Okay, whatever the disinfected water is taken out from the bottom of the chlorinator. Now the chlorine reacts with water to generate hypochlorous acid. Same thing. Okay, here chlorine reacts with water to form HCl plus hypochlorous acid. Here hypochlorous acid acts as a powerful germicide, which kills the bacteria present in the water. Now coming to the advantages of this chlorination. Okay, advantages is the use of chlorine is more economical, effective and economical, and it suitable for stable and requires a small space for storage. Okay, this chlorinator requires small space for storage and does not deteriorate on keeping, and it is even used at high and low temperatures. There are some excess use of chlorine. What happens means it produces a bad taste and color, odor. Sorry, bad taste and odor. Excess chlorine produces irritation on mucous membrane. These are the disadvantages and advantages of this chlorination by chlorination. Now, what happens? We have to use the sufficient amount of chlorine only. Excess amount of use of chlorine also, there is some disadvantages. Okay, what happens? See, we need to use the calculated amount of chlorine. Okay, the amount of chlorine required to add, the calculated amount of chlorine must be added to water, because chlorine after reacts with bacteria and organic impurities or free ammonia in
Shit.
raw water. Yeah. Here in the chlorination, calculated amount of chlorine must be added to the water, because chlorine after reacts with, chlorine after reacts with bacteria and organic impurities or free ammonia in the raw water, remains in the water as the residual chlorine. Okay, this residual chlorine is again harmful. Okay, this residual chlorine is again harmful. This gives the bad taste, odor, and toxic to the human beings. So we need to use the calculated amount of chlorine only. Okay, if you use excess also, it creates the bad taste, odor, and toxic to the human beings. So what we call it as, okay, the amount of this process of applying the calculated amount of chlorine is called as breakpoint of chlorination. Break point of chlorination. The amount of the process of applying the calculated amount of chlorine to water in order to kill the pathogenic bacteria. What is the reason why we are using this chlorine? To kill the bacteria present in the water. Okay, this is known as breakpoint of chlorination. The calculated amount of chlorine must be added to water, because chlorine after reacts with bacteria and organic impurities or free ammonia in raw water, it remains in the form of, okay, it still remains in the form of residual chlorine. Okay, it remains in the form of residual chlorine. This residual chlorine is harmful. Okay, this residual chlorine is creates the bad taste. Okay, bad taste, odor, smell, and toxic problems to the human beings. Okay, so for this purpose we need to add the calculated amount of chlorine only. The disinfection will not complete if chlorine is insufficient. Okay, if excess also chlorine is also is added, okay, it causes what? Irritation, bad taste, and odor. So we need to apply only calculated amount. That is, the process of applying a calculated amount of chlorine to water in order to kill the pathogenic bacteria is called as breakpoint of chlorination. Okay, the process of applying the calculated amount of chlorine to water in order to kill pathogenic bacteria is called breakpoint of chlorination. See, the amount of chlorine required to kill, okay, same definition. The amount of chlorine required to kill the bacteria to remove the organic matter present in the water is called breakpoint of chlorination. Here, water sample is treated with chlorine and estimated for the residual chlorine in water. Okay, water sample is treated with chlorine and the estimated for the residual chlorine. What excess of chlorine leads to the residual chlorine in water. Okay, a plot is graph between the amount of chlorine added and the we need to add the amount of chlorine added and residual chlorine. On the x-axis we need to take chlorine added and the residual chlorine. We will get the graph like this. A graph is plotted which gives the breakpoint of chlorination. At which points, okay, we need to add here we need to take A, B, C, D like that. Okay, water sample is treated with chlorine and estimated for the residual chlorine in water. A plotted graph which gives the breakpoint of chlorination. Okay, this is the graph mark. Okay, here this is called a breakpoint of chlorination. Breakpoint of chlorination. Okay, at A, B, C. Here A, B, C. See if A grams of chlorine means the sufficient, whatever the amount of chlorine added to remove the pathogenic bacteria present in the water. Only if you take A grams, okay, example A grams of chlorine added, it oxidizes impurities present in the water. Okay, if B grams of chlorine added, it forms chloramines and other chloro compounds. Okay, if the C grams of chlorine is added, okay, if you add C grams of chlorine added, causes the destruction of bacteria. Okay, this is called as, this C grams is called as a break point of chlorination. Okay, if you add more D grams, okay, if you add sufficient more than the calculated amount, here C is a calculated amount. Okay, it is somewhat less than A. Okay, A is, if you take A as 10%, okay, it is 20%, and this is the sufficient amount. Okay, this is the amount required to break the destruction of pathogenic bacteria present in the water. This is called as break point of chlorination. This sufficient amount of chlorine added to destroy the destruction of bacteria, pathogenic bacteria present in the water is called as break point of chlorination. Here again, if you add excess of chlorine, it leads to the residual chlorine. Okay, here C is called as break point of chlorination. Break point for addition of chlorine to water. This is called as break point of chlorination. Break point of chlorination. Here, if you add A grams of, yes, is it? Okay, if you add A grams, see here A is the, it helps to oxidizes the impurities present in the water. Okay, here see this is the residual chlorine on the break point of chlorination graph mark. This is the y-axis and this is x-axis, chlorine added. Okay, at this point, okay, this point we call it as break point of chlorination. Here the bacteria, okay, the amount of chlorine added to kill the bacteria, okay, pathogenic bacteria present in the water is called as break point of chlorination. A, B, C. A helps to remove the impurities present in the water, and the B is the use of this B grams of chlorine helps in chloramines. Here see, this is a trihalomethanes monochlorochloramine. Okay, here B grams is, okay, this is the B, A, B, C. See here C grams. This point we call it as break point. Okay, this C is called as break point of chlorination. C grams of chlorine. Here this point, the it helps to remove the kill the bacteria, pathogenic bacteria present in the water. Pathogenic bacteria present in the water. If you add excess of this is nothing but residual chlorine. Okay, this is, if you say think it as D. Okay, this is called residual chlorine, and this residual chlorine again leads to the bad effects, bad taste, bad color, and toxic to the human beings. Okay, see this C grams of chlorine added causes the destruction of bacteria. That is called as break point of chlorination. Break point of chlorination. Now coming to the advantages of this break point of chlorination is, okay, it removes the, okay, this removes the bad taste, color, oxidizes completely organic compounds, ammonia and other reducing impurities present in the water. Okay, what is the advantage of this break point of chlorination is, okay, it removes the bad taste to the water, color, oxidizes completely organic compounds in ammonia, other reducing impurities, and it completely destroys the all disease producing bacteria present in the water. Okay, this break point of chlorination is destroys the completely all disease producing bacteria, nothing but pathogenic bacteria that is present in the water. Next method, okay, in the disinfection we have discussed about the boiling and by chlorination. The third one is by using chloramine. Okay, again the chlorination we have bleaching powder by chlorination. Third one is by using chloramine. Okay, what is the uses of this using chloramine? Okay, this how we got this chloramine means it is obtained by, okay, this is obtained by mixing chlorine. Okay, chlorine with ammonia, you will get the chloramine. Chlorine Cl2 plus NH3, it forms NH2Cl plus HCl. This NH2Cl, we call it as chloramine. Okay, now this chloramine, what happens? This chloramine reacts with water. This chloramine reacts with H2O to form HOCl, hypochlorous acid plus ammonia. This hypochlorous acid acts as a powerful oxidizing agent. Okay, powerful disinfectant. Okay, this kills the pathogenic bacteria or harmful bacteria that is present in the water. Okay, you see, it is obtained by mixing chlorine and ammonia in 2:1 ratio to form a stable chloramine, which generates hypochlorous acid. Which generates hypochlorous acid. So this hypochlorous acid is a powerful disinfectant. Powerful disinfectant. Okay, it kills the harmful or pathogenic bacteria present in the water. That kills the bacteria. Here, hypochlorous acid inactivates the enzymes of bacteria. Okay, whatever the enzymes that are present in the bacteria is inactivated by this hypochlorous acid and kills the bacteria. So it is called as a powerful bactericidal action. Okay, it is a better bactericidal action than chlorine. It is more stable and non-producing any irritating odor. So that is the use of this hypochlorous acid. It does not produce any irritating odor. So it is if this is commonly, this chlorine is useful for the disinfecting swimming pools. Okay, in the swimming pools we can use these chloramines. Example is chloramine is useful for disinfecting, means removing the harmful. Okay, sterilizing the water in the swimming pools. So this is how this hypochlorous acid kills the bacteria present in the water. Okay, it inactivates the enzymes present in the bacteria. Yeah, enzymes present in the bacteria and kills the bacteria. So it is a better bacteria, means germicidal action than the chlorine. Okay, it is better than the chlorine. So it is more stable and non-producing any irritating odor. Now, third one is disinfection by ozone. By using ozone, how we are going to kill the bacteria present in the water. Okay, ozone is an excellent and harmless disinfectant. Ozone is an excellent and harmless disinfectant since it produces nascent oxygen. See, O3 is a produces O2 and nascent oxygen. O2 is nothing but oxygen. This is a nascent oxygen. This is highly unstable. Okay, this nascent oxygen is highly unstable. This is unstable form. Okay, this is a stable. O2 is in stable form. Unstable, and this acts as a powerful oxidizing agent. Powerful oxidizing agent means which kills the organic matter present in the water and also kills the bacteria. Okay, this nascent oxygen acts as a powerful oxidizing agent. Powerful oxidizing agent. Okay, it kills the bacteria and organic matter and bacteria present in the water. It kills the organic matter and bacteria present in the water. Okay, here how we are going to do this disinfection by ozone. Okay, yeah, disinfection by ozone. How we are going to do this is perform this experiment is ozone is injected into the water. Ozone is nothing but O3 is injected, means here introducing the ozone into the water, and the two are allowed to come in contact in a sterilizing tank. Okay, this sterilizing tank for about 10 to 15 minutes. Here, disinfected water is removed. Disinfected water is removed from the outlet at the top of the sterilizer. Okay, here we are going to introduce the water. Okay, this raw water inlet is this one, ma. Okay, we are passing ozone from this side. Okay, we are injecting the ozone from this side, and they are allowed to come in contact with sterilizing tank. Sorry. Okay, disinfected water is removed from the outlet at the top of the. Yeah, here water outlet is present, ma. Here water inlet. This is the water inlet. This is a water inlet, and this is a water outlet. Okay, we are passing the ozone from the ozonator. This is the ozonator. Ozonator. From here we are passing the ozone. Okay, ozone we are injected into the from this side. They are allowed to come in contact with this tank. This is the sterilizing tank. Sterilizing tank here for about 10 to 15 minutes. Okay, here whatever this water, this is the water inlet. This contains this raw water, which contains all the organic matter like okay present in the water. Okay, is removed from the outlet at the top of the sterilizer. Disinfection of municipal water supply is not done because it is expensive method. Okay, this method is cannot be used in this municipal water treatment. Okay, this disinfection of ozone cannot be used in the municipal water supply because this is one of the expensive method. This is about water treatment process, ma. Water treatment process, raw water from the river. Okay, we followed by the filtration, coagulation, sedimentation, filtration, disinfection, treatment for the storage, and the next to distribution. This is the water treatment process. Water treatment, water from the raw water from the rivers or move to the coagulation, segmentation, filtration. Next, disinfection. This is a disinfection by different methods. Next, for storage in tanks, followed by the distribution. Treatment process, water treatment process. Now, the next last topic in this module 2 is desalination. Desalination. What actually the desalination is? Okay, the process of removal of salts. Okay, dissolved salts present in the water is nothing but desalination. Here, desalination is then there are several methods of desalination, but in our syllabus we have reverse osmosis. By using this reverse osmosis, we are going to convert the impure water into the pure water. Okay, dissolved salts, water present in the dissolved salts are removed by the reverse osmosis method. Now coming to what is here desalination of brackish water. Desalination of brackish water. What actually this desalination is? Okay, water containing high concentrations of dissolved salts. Okay, with a peculiar salty or brackish taste is called brackish water. Okay, what is the meaning of brackish water? Is nothing but brackish water is the high concentrations of dissolved salts with a peculiar salty or brackish taste is called brackish water. Here example for this brackish water is seawater. Seawater is an example for the brackish water. It contains about 3.5% of dissolved salts. Okay, the process of removal of these dissolved salts present in the water is called desalination. Removal of salts, dissolved salts present in the water is called desalination. Okay, here what is brackish water? Brackish water is nothing but here the water containing high concentrations of dissolved salts with peculiar taste or brackish taste is called as brackish water. Okay, peculiar salty or particular taste, brackish taste is brackish water. Your example for this brackish water is the sea water. Okay. Now, before this removal of salts, it is unfit for most of the domestic and industrial applications. Okay, this is unfit for domestic and industrial applications. Now, the process of removal of dissolved salts like NaCl present in the water. Okay, the process of removal of dissolved salts like NaCl present in the water is nothing but desalination. Okay, the process of removal of dissolved salts present in the water is known as desalination. Coming to the water, yeah, is divided into three categories on the basis of salinity. Okay, based on the salt presence. Okay, salts present in the water, it has been categorized into three types. First one is sea water. Okay, how much amount of salts present in that? Okay, the salinity is greater than 35,000 milligrams per liter. Okay, the salinity of this sea water is greater than 35,000 milligrams per liter. In the brackish water, the salinity range is in between 1,000 to 35,000 milligrams. Okay, and it is peculiar salty taste. And the fresh water is the salinity of water is less than 1,000 milligrams per liter. So that is the reason we are not using this brackish water or sea water for the drinking. The reason why, because why we are not using the sea water and the brackish water for drinking is the salinity of this sea water is greater than 35,000 milligrams per liter, and the brackish water is 1,000 to 35,000 milligrams per liter, and it is a salty taste, particular salty taste. So the fresh water, the salinity of fresh water is less than 1,000 milligrams per liter. Okay, so that is the reason we are not. It is not fit for drinking. Brackish water and sea water is not fit for drinking as well as for industrial purpose. The reason behind why we are not using the sea water and brackish water is this is the reason. The salinity is the reason for not fit for drinking. Not useful for the drinking is salinity, and now they are subject to desalination because now we are doing desalination process to this brackish water. Desalination of brackish water is the topic here. Desalination of brackish water means removal of dissolved salts like NaCl present in the water is nothing but desalination of brackish water. Here, coming to the techniques for the desalination is, okay, what are the techniques involved in the desalination is reverse osmosis, okay, reverse osmosis, electrodialysis, distillation, and freezing. These are the techniques involved for the desalination of brackish water. Desalination of brackish water. Coming to the, in our syllabus, we have only reverse osmosis. Reverse osmosis method is used for the desalination of brackish water. What actually this osmosis means? What is the definition of osmosis? Anyone define osmosis? Osmosis definition. Yes, what is osmosis? Yeah, coming to the definition of osmosis is, okay, the momentum of okay, when two solutions of unequal concentrations are separated by a semi-permeable membrane, okay, which does not permit the passage of dissolved solute particles. Here the flow of solvent takes place from the dilute solution to concentrated solution. This is called osmosis. The simple definition of osmosis is momentum of particles from the high concentration to the low concentration is called as osmosis. but for the desalination of brackish water, we are doing in a reverse way. That is nothing but reverse osmosis. Okay, reverse osmosis. Actually, the definition of osmosis is the momentum of particles or particles from the momentum of particles or ions from high concentration to low concentration, that is called as osmosis. But here in the desalination of brackish water, we are doing in a reverse way. That is nothing but reverse from the low concentration to high concentration is nothing but reverse osmosis. Okay, when two solutions of unequal concentration are separated by a semi-permeable membrane. Okay, this membrane is made up of cellulose acetate. Okay, this membrane helps to momentum of particles from one end to other end. Okay, one end to other end. Here, unequal concentrations are separated by a semi-permeable membrane, which does not permit the passage of dissolved solute particles like molecules or ions. Flow of solvent takes place from dilute to concentrated, means low concentration to high concentration. This is called as osmosis. Flow of solvent takes place from the dilute solution to concentrated solution. This is called as osmosis. In this process, solvent can be flow but not solute. Okay, in the solution, there is a solute and solvent will be present. Less solute and solvent will be present. This solute and solvent we call it as solution. Okay, solute and solvent we call it as solution. Here only solute is nothing but less quantity, less concentrated solute, and the more amount is nothing but more concentration is nothing but solvent. Okay, these two mixture we call it as solution. Only solvent can flow but not solute, which produces a pressure called as osmotic pressure. Osmotic pressure on the side of the more concentrated solution. Okay, here this osmotic pressure is created by water moving across the membrane due to the osmosis is called osmotic pressure. Osmotic pressure is nothing but pressure created by the water moving across a membrane due to the osmosis is called osmotic pressure. Okay, by applying the osmotic pressure, okay, the solvent flow from the more concentrated to high. Okay, let's concentrate it. Here this is osmosis method, but we are using in a reverse way. See how this is a membrane. Here low concentrated dilute solution is present, having high concentration of water molecules. Concentrated solution containing low concentration of water molecules. Here what actually the osmosis? Osmosis is a process by which flow of solvent takes place. Flow of solvent takes place from a region of low concentration to high concentration. Okay, already I defined this one. Solvent takes place, the flow of solvent takes place from the region of, okay, low concentration to the high concentration, which two solutions of different concentrations separated by semi-permeable membrane. Okay, the flow continues till the concentration is equal on the both the sides. Here the flow continues till the concentration is equal on the both the sides. Now, reverse osmosis. The principle involved in the reverse osmosis is, okay, this is a membrane filtration. Okay, hydrostatic pressure in excess of osmotic pressure is applied on concentrated site. Hydrostatic pressure is in the excess of osmotic pressure is applied on the concentrated site. The flow of solvent reverses as it forces to move from concentrated site to dilute site. Okay, concentrated site to dilute site across the membrane. This is the basis for the reverse osmosis. Okay, it is in a reverse osmosis. The reverse osmosis, here we are applying. Okay, this is the membrane, semi-permeable membrane is there. Okay, here from this side, what salt water is present here. This is salt water. As we applying the osmotic pressure is applied from this side. What happens? The hydrostatic pressure exceeds the osmotic pressure applied on the concentrated side. Here the more amount, concentrated means more amount of particles are present over here, and the flow of solvent reverses. What happens? It is reverses across the membrane. This is nothing but reverse osmosis. This reverse osmosis, pure water is separated from the contaminated. Okay, this is it contains the contaminated water. The water, this is the semi-permeable membrane. Okay, this water, whatever the water coming from this side is the fresh water. That is nothing but the pure water. Pure water. By applying the osmotic pressure, okay, whatever the salt water, it contains the contaminants. By applying the osmotic pressure on this, okay, the solvent, the flow of solvent reverses as it forced to move from concentrated. Okay, this is a concentrated side to the dilute side. Okay, dilute side across the membrane. This is the concentrated side, and this is the dilute side across the membrane. This is the semi-permeable membrane. Okay, when we apply the osmotic pressure on this side, what happens? Okay, the momentum of solvent molecules reverses as it forced to move from the concentrated to dilute across the membrane. Okay, it helps to dilute to concentrated dilute across the membrane, and this is nothing but reverse osmosis. Okay, now by using this reverse osmosis, we'll get the fresh water. Okay, fresh water. The reverse osmosis, pure water is separated from the contaminated water. Okay, the salt water, this is a pure water we got by using this semi-permeable membrane. By applying some osmotic pressure on this side, okay, salt water gets converted into the fresh water. The membrane filtration is also called as superfiltration or hyperfiltration. This membrane filtration is also called as superfiltration or hyperfiltration. Here, same. Okay, different method of purification. The salt water is forced through the semi-permeable membrane. Okay, see, this is the high concentration is brackish water or sea water. Okay, we are applying the osmotic. This is the it clearly explains here. See, reverse osmosis process. This is the osmotic pressure is applying. Okay, on the top we have brackish water, that is our sea water, high concentration. Okay, semi-permeable membrane. This is the semi-permeable membrane. Actually, the osmosis will take place like this, from low concentration to high concentration, but it is taking in a reverse way. That is nothing but the reverse osmosis. Okay, salt water forced through the semi-permeable membrane. Okay, we are forcing the salt water through the semi-permeable membrane. Okay, this is the salt water is top. We are forcing them to move from the low concentrate pure water, which is made very thin films of cellulose. This semi-permeable membrane is made up of cellulose acetate, polymethyl acrylate, and polyamides. Okay, actual process we need to take place. This is the osmosis process, but it is taking in a reverse way, that is called as reverse osmosis, by applying the osmotic pressure. The salt water forced through the semi-permeable membrane, which is made up of very thin films of cellulose acetate. Okay, the superior membrane made up of polymethyl acrylate. Okay, these membranes are made up of semi-permeable membranes are made up of polymethyl acrylate, polymethyl acrylate, cellulose acetate. Okay, these membranes are made up of poly and polyamides. Polyamides are used for the semi-permeable membrane, preparation of semi-permeable membrane. Selective membranes which does not permit the passage of dissolved solute particles. Okay, this membranes helps in selective membranes which does not permit the passage of dissolved solute particles present in the water. Okay, coming to the what actually the reverse osmosis. The process is very easy. Okay, by using this water, this process, what we are going to you'll make pure water from the salt water. We are making the pure water, fresh water. Okay, it removes the ionic and non-ionic substances present in the water. The process is very easy process. Okay, use it to make pure water. It removes the ionic and non-ionic substances present in the water. It is also remove the suspended and colloidal particles present in the water. Here, life of the membrane is nearly 2 years. This semi-permeable membrane is 2 years, and it should be replaced after this period. Okay, after 2 years, we need to remove the semi-permeable membranes. Okay, by this process, seawater is made fit for drinking. Right, we are making seawater into the fresh water by using this reverse osmosis method. Okay, desalination of brackish water. Water obtained after the being treated by this process is used in the boilers. Okay, whatever the okay, we can use this water in the boilers. Boilers are nothing but steam generators. Okay, whatever the steam that generates in the boilers are used for the generation of electricity. Yeah, this method is applicable mainly for the desalination of seawater. Desalination of seawater, we are using this reverse osmosis. Here, reverse osmosis cell consists of a chamber. Okay, a chamber fitted with a semi-permeable membrane, above which, okay, it's like construction. Reverse osmosis cell consists of a chamber fitted with a semi-permeable membrane, above which salt water and impure water is taken, and a pressure of 15 to 40 kg per centimeter is applied on the sea water for the separating water from its contaminants. Okay, what we are taking, okay, this is a chamber fitted with semi-permeable membrane. Here in this above we are taking the salt water and impure water and we are applying the osmotic pressure. That is how much pressure is 15 to 40 kgs of per centimeter is applied on the sea water for separating the pure solvent from its contaminant, pure water. Okay, from impure water we are taking the pure water. This is the process. Coming to the advantages of this is this process removes the removes ionic as well as non-ionic dissolved salts easily. It is effective in removing colloidal impurities. Okay, reverse osmosis is helps to remove the ionic and non-ionic dissolved salts present easily. Effective in removing colloidal impurities present in the water, that is silicon dioxide. The process is economical and convenient. The process can be carried out at room temperature. Okay, these are the advantages. Already you know this. We are using this to convert the sea water to the drinking water, fresh water. Okay, drinking water. It is used for the high pressure boilers. Okay, this water, whatever the water, this water can be used for the high pressure boilers. These are the advantages of reverse osmosis. Okay, now coming to the applications. It is used for treatment of wastewater. Okay, wastewater can be treated by this reverse osmosis. Desalination already we have seen. Purification of water, making proceeded water. Okay, for dialysis in hospitals, for certain cosmetics and drugs by pharmaceutical manufacturers for injection. Okay, the WFI, that is water for injection. Okay, these are the applications of desalination. Okay, reverse osmosis, applications of reverse osmosis, desalination by reverse osmosis. We are taking the example brackish water. Process removes ionic as well as non-ionic dissolved salts easily. Okay, it is effective in removing colloidal impurities in water. It is economical and convenient. Okay, it can be carried out at room temperature. It is suitable for converting seawater into the fresh water. Already you know this, and it is used for the high pressure boilers. These are the advantages of reverse osmosis. Advantages of reverse osmosis. Yeah, you have any doubts? This is about the module 2. In the next class, we will start the polymers, material engineering materials, polymers. Any doubts? Yeah, any doubts in the desalination of brackish water by reverse osmosis? Yes. J4, J3. Okay. And stop sharing the screen, ma. Thank you. Yes, is that not what, sir? Okay, which one?